Hi, this is Shyamala Gauri, Assistant Professor in CSE Department, Rohini College of Engineering and Technology. Subject code CGS 355, Neural Networks and Deep Learning. Unit 4, Deep Feed Forward Networks. The topic covered in this presentation is regularization. Its key concepts and its types are explained. Introduction. Regularization is a technique used in machine learning and deep learning to prevent a model from overfitting to the training data. Overfitting occurs when a model learns the noise or random fluctuations in the training data instead of capturing the underlying patterns, leading to poor generalization to new unseen data. Regularization methods add extra constraints or penalties to the model's learning process, encouraging it to be simpler and more generalized. By preventing the model from becoming too complex or fitting the noise, regularization helps ensure that the model performs well not only on the training set but also on test data or new data. Types. L1 regularization. Lasso. L1 regularization adds a penalty proportional to the absolute value of the weights of the model. The regularization term in the loss function is the sum of the absolute values of the model's parameters. L2 regularization. Rich. L2 regularization adds a penalty proportional to the squared value of the weights. The regularization term in the loss function is the sum of the squares of the weights. Number three, elastic net regularization. Elastic net regularization combines both L1 and L2 regularization. The last function is a linear combination of L1 and L2 penalties. Fourth, dropout. Dropout is a regularization technique used in deep learning where during training randomly selected neurons are dropped or set to zero. This forces the model to rely on multiple paths and learn more robust features. During training, for each forward pass, dropout randomly disables a fraction of neurons. During testing, dropout is turned off and the full network is used, but the weights are scaled down to account for the fact that some neurons were dropped during training. Number 5, early stopping. Early stopping is a technique that halts the training process when the model's performance on a validation set stops improving. Typically, the training continues until the validation error starts to increase, signaling that the model is starting to overfit. Number 6, data augmentation. Data augmentation is a technique used to artificially increase the size of the training dataset by applying transformations to the existing data. These transformations might include random rotations, flips, shifts, and scalings of images or adding noise to data. Number 7, weight regularization or weight decay. Weight regularization are often referred to as weight decay. Involves adding a penalty on the weights during training. The idea is to penalize large weights in the model by adding a term to the loss function that discourages large parameter values. Thank you.